Hi everyone, welcome to the third day of our Health Information Exchange Standards Workshop. My name is Linda Bird. If you don't know me, I'm an adjunct assistant professor here at the University of Victoria, and I'm also an active health interoperability standards implementer and advocate, particularly in the areas of SNOMED CT and FHIR. And I'm the instructor for the UVic's HIMP 537 course on Health Information Exchange Standards, which is hosting this 3-day workshop series. So welcome, everyone. But before we get started, let's begin with our territory acknowledgement. I would like to acknowledge and respect the Lekwungen peoples on whose traditional territory the university stands, and the Songhees, Esquimalt, and Wasanich peoples whose historical relationships with the land continue to. So we've had 2 wonderful workshops already, and today is the final day of our virtual workshops. It's Wednesday, April 30th. So today's focus is all about HL7 FHIR, which of course stands for Fast Healthcare Interoperability Resources. Like the previous 2 days, we'll start with our guest presentations, and then after those, I'll be staying on with the students of HIMP 537 to work through some hands-on activities. Today, obviously all related to FHIR resources, profiling, and terminology value sets in FHIR. So if you'd like to join us for these activities next time to get a better understanding of the terminology and the interoperability standards we'll be talking about today, you can enroll in the University of Victoria's Certificate in Health Terminology and Interoperability Standards. This is a 1-year part-time program with 4 graduate level courses done through weekly online evening classes plus this virtual workshop. This is the only terminology standards program in Canada that is accredited with CHIMA, the Canadian College of Health Information Management, to become a certified terminology standards specialist in Canada. So if you'd like to join us, our September 2024 intake, our September 2025 intake, please apply by June the 1st, and you can get more information by the QR code or at our website at uvic.ca/HIMF, and then click on certificates. So here's today's agenda. We have 2 great speakers today to present on FHIR topics, Lloyd McKenzie and Irfan Kahim. First up, we're very lucky to have Lloyd McKenzie with us today to present on FHIR questionnaires and maps. Lloyd is a globally recognised expert in the HL7 standards community and one of the 3 initial editors of FHIR. He is a co-chair of the FHIR Infrastructure Working Group, a member of HL7's TSC, the Technical Steering Committee, and an HL7 Fellow. And Lloyd also leads on both the ONC and International FHIR Structured Data Capture, or SDC, projects. So Lloyd is a wealth of knowledge about FHIR, and we really appreciate him being here. So thank you so much for joining us, Lloyd, and I will pass the floor over to you.
All right. Thank you. And if the technology is functioning, you should see my screen.
That is perfect, Lloyd. Thank you.
Yay, technology that works. All right. First acknowledgement. This deck is licensed under Creative Commons Attribution. If you would like a copy, my contact information will be on the final slide. Be happy to point you at where it lives, and just wanted to say thanks to Brian Postlewaite, who developed some of this content. And as long as you retain the slide, you are free to use the deck as you see fit within your own organization. Let's dive in. Questionnaire is the resource that exists in FHIR to support forms. And forms exist all over the place in the healthcare space. It's pretty hard to visit any kind of healthcare system without being presented with a form that captures your name and address and phone number and allergies and all other kinds of stuff. We have forms in the research space. We have forms in the public health space. If you are submitting a referral, odds are that there's a form to fill out. If you are being discharged, you may get a satisfaction survey. There's forms for insurance. We don't hit that as much here in Canada as they do in other places in the world, but it still rears its head occasionally. We have checklists of various kinds. So definitely a prominent form of interacting with data. And we use forms because they're simple. We've got, this slide is a little old, it says 100 plus other resources. It's now 250-ish other resources that exist in FHIR. And defining separate user interfaces for every single one of those, the ability to serialize them, the ability to parse them, et cetera, is not a small amount of effort. And there's also questionnaire response, which can gather all of the information from every single one of those other resources. So in a questionnaire response, you can capture allergies, you can capture information about a care plan, you can capture information about height and weight and blood pressure and demographics and all of those other kinds of things that we use those other resources for. And so if you have a choice between implementing 100, 200, whatever distinct data models, or you can implement one data model, we easily understand why implementers often want to gravitate towards, let's do the one that can handle everything. We use forms for a few other reasons, though. Forms give us really tight control over appearance. If I look at the allergy and tolerance resource, it tells me the common things that exist. So this allergy is about this person. It identifies a particular substance that they're allergic to. It indicates how severe it is. But there's no guidance there in terms of how do I prompt for that information? What is the text that I display on the screen? What type of control do I use to gather that information? What order do I ask for different things? Is it all displayed on one screen or across multiple screens? And the reality is that how you ask for information, how you gather information will impact what you get. That's particularly important in research space, where you want a great deal of consistency so that you know that you don't have bias being introduced into your data based on, well, over here they gathered the information using one set of questions, and over there they used a different set of questions. Maybe the differences in the data between those two sites is because of how the questions were asked, not because the two sites were actually experiencing differences in populations or an outcome. And so we sometimes need to have that tight control over what the data looks like. We can also use forms not just for capture, but for rendering information. If you have really tight control over display, you can produce consistency. And consistency means that a clinician can come and take a look at this, which is a information about prenatal and gestational care. And their eyes know exactly where to look for the key information that they're looking for. And so if you are able to take data that is coming from multiple different sources and render it consistently to whatever users you have who are trying to consume that information, that reduces cognitive load and certainly makes things more efficient, especially if you can get lots of useful information on a single page. So lots of good reasons why we want to use forms in the healthcare space. And so we're then faced with the question of, well, why do we have these 250 other resources? Why don't we just use questionnaire response for everything? And the answer there is because everybody has their own. You walk into any clinic or hospital, and their admission forms will likely be a little bit different. I mean, we're making some progress in certain jurisdictions in Canada around standardizing at least some of our forms, but for the most cases, everybody's forms are different. And furthermore, even within a single organization, within a single site, the form that you're using for admission today may be different than it was 6 months ago, and certainly different than it was 6 years ago. And that makes it very difficult for us to consistently find data. The other thing that makes working with questionnaires challenging is that if I ask a question like address, and then prompt for city and postal code and stuff like that, the meaning of address is very much determined by what section of the form I'm in. Is this the address of the patient? Is this the address of their next of kin or emergency contact? Is this the address of their place of work or their primary care provider, or could be a wide variety of things. And so in order to understand the meaning of this potentially standard question, I need to understand the context in which it's being asked to know what it actually means. And that makes it really hard to query information out of a questionnaire response. If I have a repository of tens of thousands of questionnaire responses gathered by different organizations at different times and say, please find me all of the allergies for this patient, I'm going to have a really hard time doing that. And so we have a pattern that is not the only way that things happen in FHIR, but a common way that things happen in FHIR, which is that we'll use questionnaires or forms to perform initial data capture. And we'd use that especially when the data needs to be captured by relatively simple clients. So if you're capturing information on a phone or a tablet, odds are pretty good that you have a relatively simple user interface, and you don't want to update all the rules for that interface very often. And it's much easier if you can just update the questionnaire and the interface just automatically adapts. And as we're using questionnaires to do that, the happy place is that we also say, you know what? I'm asking you for your name and gender and date of birth and address and cell phone number and email address and all of that other stuff. But guess what? You've been here before, and I have a pretty good idea of the answer to all of those questions. So I'll fill in all of those answers, and then you can just override and say, well, actually, I've got a new cell phone, or I was recently married, or no, that's not my date of birth, you got it wrong. And fill in the information to change it, but not have to fill it in from scratch and have to dig into your wallet and try to remember what your provincial health number is and all of the other fun stuff. And then once we've populated the form and the user has filled out and overridden or answered the questions that we couldn't already grab out of the existing EHR, we then perform a process called extraction, where we take the information that was filled out in that questionnaire response and put it into those other resources, into a patient resource or an allergy intolerance resource or a family history resource or whatever is appropriate for the type of information that we're gathering. A whole lot of it will probably end up in observation because a lot of the questions that we ask end up going into observation. And then if we want to, we can link those things together and we can say, this observation came from this questionnaire response, or this condition came from this questionnaire response. And then we have a choice of what we pass around. In most cases, we'll pass around the discrete resources, the observations, the encounters, the care plans, the allergy intolerances, whatever. We might also pass around the provenance to say where it came from, and maybe even the source of truth, which is the questionnaire response, if anybody downstream actually cares. And occasionally they will, but most of the time they just want the discrete data record because that's what they're going to drive off of, whether that's for a Smart on FHIR application or clinical decision support or whatever it is that they need to use. So let's take a look at questionnaire. The questionnaire resource is a relatively simple resource. And you can think of it as basically one big box that contains a ton of metadata. So things like what's the title of this questionnaire, who created the questionnaire, When did the questionnaire become active? What are the identifiers for the questionnaire? Who do I contact if I have questions? All the sorts of stuff that you need to know if you're searching for the right form, and to be able to find it and be able to reliably reference it. And then questionnaires have items. And items are a recursive structure, so items can contain items, And if you want to, you can nest 50 levels deep. Most forms I've seen typically don't go more than 4 or 5, but there's no real limit, and you can have as many items as you want. So you can have a very simple questionnaire that asks 2 questions, or you can have a really complex questionnaire that has 10,000 items in it, most of which are disabled, and certain subsets get turned on and off based on how you answer. Within item, we actually have 3 different types. We have groups, we have questions, and we have display items. So groups are organizers. They don't actually gather data themselves, so you can't answer a group. Instead, it's used to capture a bunch of child items that are related in some way, and quite often that are either optional as a group or that can repeat as a group. So I might have a questionnaire and have a group that captures demographics. And then I might have a group, when I'm capturing emergency contacts, I might have a group that repeats. And so I can capture a certain set of information for each contact, like what's their name and what's their phone number and that kind of thing. If you have a group, you have to have children, or at least if you are at the point where your questionnaire is done being authored. If you are still in the drafting stage, then you might say, well, I'm going to put some demographic stuff here and not bother to define what those questions are yet. That's okay. But once you say that this question is ready to use, you have to have children. Questions are straightforward. They are the things that are going to gather information. So every question is going to say what kind of information it's going to gather. Is this Boolean? Is this coded? Is this a string? Is this a number? Is this a pointer to some other resource out there? Because we can do things like that in FHIR that you can't do with paper forms. It's possible to have a question that is optional though. So yes, it can gather data, but it doesn't necessarily mean that you'll always get data, because the individual either might refuse to answer it, or it might be that the question is conditional and only gets turned on in certain circumstances. And so if you ask questions about gender, you might then disable certain questions based on gender. Of course, there's risks with that, because the answers to those questions don't necessarily give you solid information about what the organs and other things of the individual in question might be. So we have to be careful. Display items are items where we aren't gathering information and we're not organizing anything, we're just displaying text. And we do this because sometimes we want to provide instructions or help text or legalese or other kinds of stuff that people need to be able to read, but it's not really organizing anything and it's not soliciting data. It's just, please present this to a human being so that they have a clue what's going on elsewhere. So it's supper time-ish. So this is a good time to ask about pizza. And so if we take a look at this, this is a item that could appear in a questionnaire, and specifically it is a question type of item. And so if we break down what this actually means in questionnaire terms, we have a prefix. You don't have to have prefixes, they're optional. They're primarily useful if you want to talk about particular questions. If you want to say you must answer at least 5A or 5C, if you want to provide that as instructions, it's kind of helpful if you actually have something that is called 5A and 5C on the screen. The other reason that they're somewhat helpful is if you need to provide support. So somebody says, yeah, I was filling out the questionnaire and it hung on one of the questions. natural follow-up question is, which question did it hang on? And it's much easier if you can say 5A than the one that says, what pizza toppings would you like? Both approaches work, but one's a heck of a lot faster to jot down for the help desk. Next, we have the text of the question. And by the way, these are things that can exist for both questions and groups, and even theoretically display items. You won't necessarily have a prefix for a display item, but it's not wrong to have one. If we have text in a group, it would just be the label for the group. Here, we actually have a child item, which is a display item, in this case, that is nested underneath the question. And this particular child item implies a couple of other things about the parent question. Specifically, it implies that the parent item is required. If you say choose at least one, then you have to kind of answer. And it's also a repeating question, so you can answer more than one thing. You are allowed to have more than just cheese on your pizza, which is good, because I'm one of those people that wants more than that. And then we've got our list of choices. You won't have this for all questions. If you've got a questionnaire item of type dates or integer, you may not have these, although you can. You can have a choice of dates where you say, pick one of these 5. This would probably be a coded choice, although you can also just have these things as strings if you want to. And then we get to another nested question, which is the please specify. So if you pick other, and only if you pick other, are you going to get prompted for additional information? And one of the features that we have in questionnaire is the ability to turn items on or off based on previous answers. And so we have the ability to say, if they choose other, then please prompt them for this additional set of information. So if we go look at the actual diagram of the questionnaire resource, we can see the same things that I just talked about. So here on the left is essentially that big box of metadata. So every questionnaire, unless it's a contained questionnaire, is going to have a URL, which is how we refer to it. It may have a title, it'll have a status, it'll have what kind of subject is this about. You can have questionnaires that are about patients, but you can also have questionnaires that are about organizations or practitioners or locations or for various other kinds of things. You can have a questionnaire that is about anything you like, and all sorts of other metadata intended to help you figure out, is this the form that I should be using right now? So you can filter by the type of individual it's about, filter by whether it's active or not, whether it's been approved, all of those kinds of things. Then we have our items, and this has that nifty little recursive box on it that says items can contain other items. Every item has a link ID. You can think of that as the primary key for this particular question. And that's how we're going to know that what we're answering. And then we have other metadata. So we'll have a type that says what kind of a question is this, flags of whether it's required, repeating, some other various constraints like maximum length for a string. We can have initial values. We can have our list of options either by enumerating them or pointing to a value set that's defined somewhere else. And we can have rules about when we want to turn this thing on or off. When we have a questionnaire, we're going to expect to also have questionnaire responses. So in FHIR, these are handled through 2 separate data structures. There is actually an SDC project in IHE as well. And in that space, they actually use the same data structure to both define what the allowed questions are, as well as to capture the data. In FHIR, we use 2 different structures, and that means we need to link them together. And so we do that using link ID. So here, we can see that I've got a group. It has a link ID of G1. It's a repeating group. And so I'm allowed to have multiple items in my questionnaire with link ID of G1. G1 is unique on the questionnaire side, not necessarily unique on the questionnaire response side because things can repeat. And then within G1, I've got a series of questions. The first question is, what is your name? This one is not flagged as repeating, so I'm only allowed to have a single answer to this. However, I'm still going to see two Q1s on the response side because it's nested inside a structure that can repeat. And so this is how we manage that process. So that is a whirlwind tour of the base FHIR specification. And now I'm going to talk a wee bit about structured data capture. Structured data capture came about because of the methodology that FHIR uses when we define resources. One of the key precepts that we have is that we only include things in the core resource that we believe that most systems are actually going to have support for. It's called the 80% rule. So the general rule is we're only going to include it if we believe that roughly 80% of the systems that support the resource at all will support a given data element. And with questionnaires, they're used all over the place. And so there's a wide range of sophistication of systems that are handling questionnaire data. Some of them are really, really simple, and some of them are really, really sophisticated. And so if we only include the things that most systems do in the base resource, the question then is, how do we define all of the capabilities that more sophisticated systems want to be able to do and want to be able to standardize that we cannot accurately say that most systems do? And the answer to that, as with everything in FHIR, is that we define implementation guides. And so SDC is an implementation guide that is a grab bag of different functionality that some subset of advanced questionnaire or form rendering or authoring tools need to be able to handle, and tries to standardize those things because the base specification doesn't. So we cover a bunch of different things. We cover workflow, we cover display, we cover behavior and logic. We have the ability to populate forms, extract information from forms, do adaptive forms, assemble forms, and we have different sections for all of those things. So the workflow portion of SDC does things like, what should you support out of questionnaire if you're wanting to let people search for a form? What are the capabilities that the form filling system needs to have and the form manager needs to have to look up values and to do all of the terminology stuff that's necessary? How do you say, please fill out a form and have somebody be able to respond, here you go, or no, I don't want it today, or whatever the response happens to be? How do you send a completed form to somebody? Sometimes it's, please just store this on your system and I can then query it and update it. Other times it's, please process this, and it goes off into a black box and you can't see it anymore. And so it's helpful to be able to sort of categorize the types of systems that interact with forms. And we've done that with a step of standard capability statements and say, these are common pieces of functionality that a system might have. And so we can talk about form filler and say, these are the things that a form filler should be able to do, and standardize that language. And so nobody should ever say, I'm conformant with SDC. That's meaningless. However, you could say, I am conformant as an SDC form filler, or an SDC form manager, or an SDC form response manager, or maybe all of the above, because I'm a Swiss Army knife and I can do all of these things. And that then is much more specific in terms of what it is that you do and what the expectations that somebody else can then have about what your system is capable of doing. In terms of rendering, the base form lets you specify the text to display, the link ID to display, the order in which things are asked, but it doesn't do a heck of a lot more than that. And there's an amazing amount of different kinds of things that people want to be able to do when they're describing forms that look exactly the way they want them to. So sometimes that's having control over the color or the style of the text. I want certain things to be bold or italic, or I want this to be bigger, or I want this to be superscript, or maybe I want to embed images. Maybe I want to flag certain things as read-only. So I'm going to display your calculated BMI, but I'm not going to let you edit that because I've already captured your height and weight, and it's a calculated thing, and it doesn't make sense to let you edit that because that would then make it wrong. Or maybe I'm going to have some hidden stuff. So I'm going to go and look up your primary care practitioner. You will use a drop down and you'll type in their name or whatever, and you go, yes, that's them. They're Dr. Jones on 105th Street. And that's great. And you might display that in your answer. But behind the scene, you probably also want to capture what is the URL of Dr. Jones on that particular provider registry. And if you display that on screen to the human being, they're going to go, what's that ugly GUID thing that's sitting there? And they will be unhappy and they will be confused. But capturing that as a hidden question is useful. You might want to have control over what is the controls that are being used. So is this a drop down? Is this a slider? Is it a knob that you can turn? Should things be radio buttons? Maybe you want to display things in a table and you've got a list of questions with the different answer choices in columns. And we can define all of those things. Maybe you want to prompt and say, if you're filling out a phone number, here is the syntax that I would like you to use when you're filling that out. And we have that ability to capture all of those different kinds of things in FCC. We can also do complex behavior. So things like turning things on or off. The base questionnaire lets us do that based on single answers. But we may also want to do that on more sophisticated things, like I'm calculating a score as we go. And if their score is in a certain range, then I want you to ask more questions because I've already identified that they are a potential risk for something. And so now we want more detail. Sometimes we want to control what answer choices are displayed in certain circumstances, or we want to have rules rather than just on terms of a single answer. We want to have rules that span multiple questions. So maybe you have to have a total number of your answers add up to 10, or maybe you pick your priorities 1, 2, 3, 4, 5, and there's a rule that says you can't have more than one thing that is a priority level 1 or 2. And so we can do that kind of rule setting with SDC. We can also constrain what your allowed values are. So we had already the ability to set a maximum length because that was deemed to be a pretty common feature. Setting minimum length was less common, so there's extensions to do that. But we can also set ranges, so minimum value, maximum value, whether we're talking dates or quantities. We can, if you're doing an attachment, say, I'd really rather if you didn't attach a WordPerfect 3 document because I don't know how to parse that anymore. Or I don't really want a 5 terabyte radiology image, thanks. 200K JPEG is fine. We can constrain the units of measure for our quantities. We have the ability to say that this is a mandatory question or this is a repeating question in the core spec, but sometimes we want to be tighter than that. We want to say you have to have at least 3 or you can't have more than this many answers. And so we can set those values in as well. One of the things that we can do with questionnaire that we can't do in the paper form world is point to other resources. One of the things that we do all the time in FHIR is point to things. It's kind of very much like web pages where you embed hyperlinks, and if you want to see more, you follow the hyperlink to go look up the details about the patient or the ordering provider or the delivery location or whatever it is. The base questionnaire lets us do that, but doesn't provide any way of setting the rules for what am I pointing at. And typically we want to set rules, because if we ask, please select your primary care provider, we don't want somebody to point to an allergy intolerance, because that's not useful. And furthermore, if we're asking them to point to a practitioner, we probably care what system they're looking for the practitioner on. And so we can do that. And in fact, if you want to get super fancy, if you look on that registry and you can't find the practitioner or whomever it is that you're looking for, you could say, and if you can't find them, go use this questionnaire to create a brand new entry in that registry that we can then select. So all sorts of fancy things that people have decided they want to do with questionnaires. The last thing I'm going to talk about in terms of complex behavior, we want to be able to calculate scores. We want to be able to automatically know who is the patient that we're looking at, who's the user, what's the current encounter, that kind of thing. We want to be able to have variables where we're storing information as we go that we're going to reference in other kinds of places. We might want to be able to build forms from other forms. So if I got a standard set of demographic questions, rather than maintaining those on my 378 different questionnaires, I just maintain my demographic questions once. And then in my other questionnaires, I say, go include that section. And then if I want to update and say, you know what, we now capture pronouns. Instead of having to update 378 different questionnaires to add pronouns, I now update one questionnaire fragment to add pronouns, and voila, that's now available in all of my questionnaires. We can also have standard questions. So I can point to a questionnaire library and say, that's the question that I want, and leverage the expertise that exists within my organization about how to write good questions and ask the same thing in the same way in different places, and therefore maybe have some consistency in my data, because consistency in data, it makes people happy. And so we have that ability. Pre-population is another big thing with SDC, because it makes life easier for whoever is filling out the form, whether that's the patient or the practitioner. And it also increases the quality of your data, because if you have somebody who needs to type something in or transcribe something that they are looking at in one place into another place, bad things happen when people type or try to pull things in their head and put them somewhere else. And you get typos, you get things that are missed. Whereas if we can just go grab the data, that's much less likely. When we go grab the data, we still generally want a human being to look at it and say, yes, this is in fact right. Maybe I'm going and grabbing the most recent weight that I have for you, and you go, actually, no, I've lost 10 pounds. Or, well, that was before Christmas. And I'll get back there someday, but that's not what my weight is today. We have the ability to override, but it's nice to have the initial value there as a starting point. In order to do population, you need to have a data source that has a FHIR API. So typically an EHR, could be a centralized jurisdictional registry, could in theory even be a clinical document, like a patient health summary. You then also need in your questionnaire to have instructions about how to map from that data source. Say, we're going to grab first name from here, we're going to grab phone number from here, we're going to grab most recent systolic blood pressure from here. And then we have an engine that knows how to execute those mapping rules and go and find that data and fill it in. In order for this to work, you do need to have a degree of consistency of your data. If you have no idea what code system is being used for allergies or conditions or observations, you're going to have a really hard time finding if this patient has diabetes or what their blood glucose is, because you don't know what codes are being used. And so the presentation a little bit later on CA Core helps us to nail down some of those things. And most jurisdictions either have or are in the process of building a set of core profiles that nail down some of those base, how do we code things here, so that you can do things like this population. There's a number of different mechanisms that are supported in SBC for population. And we support those different mechanisms because they're different level of complexity to author things, but they can also accomplish different levels of sophistication. So with observation-based population, it's the simplest. You may have noticed when I quickly brought up the questionnaire resource and we were looking at questionnaire item, one of the things that you can specify about an item is a code. And the purpose of that data element is to say, this code defines the meaning for this particular question. And so we can have a code that says, this is the systolic blood pressure, or this is a first name, or a date of birth. And those codes are there to help identify meaning and help support mapping. But one of the things that we can use for them is to say, go and find observations with this code. And if you can find them, use that to populate this answer. The only thing that we need in addition to the code to do this successfully is a sense of how far back do I look. So if I want to fill in what is my blood type, it's perfectly reasonable for me to go and grab an observation that's 50 years old, because my blood type is not something that's likely to change. Apparently blood types can change if you have certain types of bone marrow transplants, but humans are just weird and medicine is awesome. But most of the time you can be safe with doing something like that. On the other hand, if I were to go and grab my weight from 50 years ago, that would be concerning in terms of my medical record. And so we typically want to set what is the period in terms of how far back I'm going to go. And then once we've done that, inside of our questionnaire, where we've got codes that say this thing corresponds to body weight or measured body weight or dry body weight, we've got a text for our question, we've got a list of answer options in terms of our units of measure, and we've got observation link period here that says, I'm interested in anything that is done within the last 3 months in terms of body weight. If it's older than that, then I don't trust it. And we just turn that into a question. So we know who the subject is because we've got a subject on the questionnaire. We've got our list of codes, so we plop those in. We only want the completed observations. We don't want the ones that are entered in error or draft or whatever. And we fill in this date. We calculate what is 3 months ago as of today. And then we're going to sort based on date, and we're going to go grab the most recent. And if we find something, that then becomes the answer. So relatively simple thing to do in terms of authoring a questionnaire, not super hard to say, these are the codes that apply, or to fill in an extension that says, and here's how far back you can go. And then the system just does the magic. Problem with that is that it will only grab information that is stored in observations. And while there actually are LOINC codes for things like first name and last name and date of birth, the reality is that most systems don't actually store that information as observations. They will store that on the patient resource. And similarly, they probably won't store the start date of the encounter or your discharge reason as an observation. You will need to gather that from the encounter resource. And so FHIR path says we can actually do more than just look at a code. We can provide a full FHIR path. FHIR path is a syntax that's used in FHIR, but it's not actually FHIR specific. You can use FHIR path with V2 and CDA and all kinds of other data structures that you want as well. But it's syntax agnostic, which means we don't care if your data is JSON or XML or RDF. We can execute against it, and it has some other nice features that make it pretty easy and lightweight to author with. And with this, we can say the initial value for this particular element is patient dot name where use equals legal dot family, and we're going to grab the first repetition of those that we find. And so we can apply all kinds of filters in terms of what data we want and navigate through it. And we can say this particular structure is repeating, and we're going to repeat on that every time we have a patient.contact. We'll create a new one of these. And we can go and query things and say, I'm going to go grab these conditions, I'm going to go grab these allergies, I'm going to go grab these other things. Very powerful. But it does mean that you actually have to write the FHIR queries to go grab the data. You have to write the FHIR path to say where the data is coming from. You have to think about what data could theoretically exist and how you're going to filter it. So it's more work when you're authoring questionnaires. There's two other mechanisms. There's structure map, which is a transformation language, not well understood by very many people, but you can do all kinds of weird, wild, and wonderful things with it. And we also have CQL, which is basically a full-blown programming language that is built on top of FHIR paths, but is also syntax agnostic. And with that, you can define queries. You can define all sorts of conditional logic to fill things up. On the other side, we have extraction. And again, there are multiple different ways of extracting information. So we can do observation-based, which again is driven by the codes. In this case, we have to pick which one is used. When we're populating, if you have a list of 3 different link codes for weight, that's great. We're happy to grab any one of those, but when you are extracting, we need to know which one we're going to use, because not all of them necessarily apply. And we have additional rules about things like if I'm grabbing children, so I've got a, say an APGAR score, and I've got multiple components, that we want those to come as components, not as separate observations. Whereas if I've got a panel of a blood panel, I do want those as separate observations, and I want to link them using has member. We have some additional extensions that drive things like that. Definition-based, like we have code, we also have the ability to have definitions, and we can say, based on this profile, we're going to fill out these particular elements and specify the path of those elements. And if the profile has fixed values, those will automatically get filled in. If the profile has slices for different types of identifiers or addresses or names or whatever, we can leverage that information as well. There's some limitations there, though, in terms of how sophisticated we can get. So we also have a template-based, where we basically say, here is my condition resource or allergy intolerance resource or whatever it is I want to extract. And here's all the fixed values for it. And then these values are not fixed. So go grab this one from there, go grab this one from there, and just embed little pointers to say where we want information to be filled out from. And then finally, we have structure map as well. Just as we can transform a result of a bunch of queries into a questionnaire response, we can transform a questionnaire response into a transaction bundle that will create or update whatever resources we want. We have a bunch of different tools in the SDC specification for creating questionnaires, and for that matter, for answering questionnaire responses. And this list is actually out of date, so I'm just going to quickly bring up the SDC spec and show you how to find the current list now. So if you click on support and existing implementations, that will take you to a handy Confluence page that lists all of the tools that people have chosen to share that support different portions of FTC. So there's a growing list and description of what each of them do. Some of them are open source, some of them are proprietary, but you can go leverage that information. The last thing I'm going to talk about is adaptive forms. So with an adaptive form, rather than specifying this is the complete list of questions and all of the logic, I'm going to be dumb. I'm not going to show all of the rules. I'm not even going to express the rules in an interoperable way. I'm just going to expose an interface, and you can hit that interface and say, what's the next question? And I'll give you a question. So what's your name? I provide an answer. Ask again, what's your name? What's your question? Get back an answer. Ask another question. When I put together this deck initially, it's just being a little bit funny, but I learned just how geeky the standards community is, because there are actually standard link codes for all of these questions. That just made my heart happy. And so this adaptive form approach means that the form fillers can be lighter weight because they don't have to have all of that logic about should I turn this on or not. They just say what's the next question and get asked. And it also means you have a whole lot more sophistication on the questionnaire side. In fact, you could drive this from AI such that every single person who comes here may end up with different questions being asked based on contextual information or data that you already know about them. So we have abilities to do that as well. So that's all I wanted to talk about in terms of questionnaires. I'm now going to jump into mapping, but maybe before I do that, I'll just pause. Did anybody have any questions about questionnaires that they wanted to come off mute and ask, or pop into chat? Just realized that there are a couple of things in chat and I don't know what those are. Okay, no questions yet.
Any questions for Lloyd at this stage? I think you're free to keep going, and we'll do some questions afterwards.
We'll do the questions at the end. That's fine. All right. So mapping. One of the things that we often want to do in the standards world is tie together one specification with another. And we do that to help us migrate from one interface to another interface. We do that to help people just get some familiarity with what the heck is going on here. If you're already familiar with version 2, this thing is kind of like that version 2 thing, or that CDA thing, or this data model that you're familiar with. Or perhaps this is where this thing lives in our internal database. There's 3 different styles of mapping that are built into FHIR that each sort of provide different levels of sophistication. So with profile mappings, I don't know what the heck happened with my slide deck. That's bizarre. Okay, I'm just going to talk then. With profiles, every data element in a profile, and we use profiles primarily to constrain resources or data types to say this is what we want to use, but we can also use profiles to map. And so any element that we specify in a profile, we can say, and by the way, this element corresponds to another element or another portion of a data structure in some other data model. And we can do that. We can have multiple. So we can say this element corresponds to this thing in CDA, this thing in version 2, this thing in X12, this thing in the Pan-Canadian health data model, whatever we want to do. And we have full flexibility in terms of what we specify as the target of that mapping. So it's not a formal language. This is not intended to be computable. I describe it as hand-wavy mapping, meaning it's enough for a human being to read and understand what's going on, but probably not enough for a computer to read and know what's going on. And it is possible to specify mappings to things that don't exist because there is no checking of the string that you're putting into that mapping element. And so there's pros to that, which means that you can say, well, this is kind of like this, and then provide a textual description that explains the difference, which is really helpful for a human being, and that a computer is not going to have a hope of understanding regardless. But it does mean that it is possible to make errors. There is an ability, because all of this stuff, of course, can then be extracted as XML or JSON or some other computable syntax, for you to do post-processing and do a cross-check and say, hey, I actually have some rules around what I expect to have on that right-hand side of the mappings in my profiles. And so I'm going to set some QA checks at the end to make sure that I have followed all of those rules. And because I followed all those rules, I can then check against my target. But it's not really intended for that. The other two mechanisms, concept maps and structure maps, are much more suitable to computable transformation. So concept maps are generally used to map codes. So I can say, here's a whole list of ICD-10 codes, here's a whole list of SNOMED codes, and here's how you convert from one of those to the other. And that includes the ability to say this is broader than, this is narrower than, this kind of overlaps, but it doesn't mean exactly the same thing. This thing doesn't map at all. And so where we have historically done all of these mappings in spreadsheets, we can now put this in a standardized syntax that we can pass to an engine that can actually execute those. So one of the things that we can do with FHIR terminology services is say, hey, I have this SNOMED code. Please translate that into ICD-10. And so long as there is a concept map available that knows how to do that mapping, it will execute on that mapping. We can also use concept maps for other purposes. So I have seen people use them to map questionnaire items to profiles or to database structures. Anytime you have a list of things and want to map it to another list of things and have an ability to check, does this thing actually exist, or be able to say this is broader than or narrower than or slightly overlapping with or unmappable, concept map will let you do that. Structure map is, as mentioned, the most sophisticated mapping mechanism. It is designed to let you transform any arbitrary hierarchical data structure into any other arbitrary hierarchical data structure. It is a complex language, and it doesn't really resemble many other kinds of things. So it's hard for me to say that it's similar to something else that you might have heard of. But it is quite potent in terms of its ability to do transformation. I guess the closest thing I could describe it as being like is XSLT, but it looks pretty different even than that. But it is syntax agnostic, so it doesn't care if you're talking about XML or JSON or CSV files or something else. And it also has the ability to evaluate maps not only against instances, but also against types. So you can define a map from one profile to another profile, or from a logical model to another logical model, and execute that map at the structure level, and it'll say, this mapping has actually got a problem because this thing here can repeat, but the thing you're mapping to can't repeat, and you're going to run into a problem. And so you can do that kind of static analysis with the structure map that you can't necessarily do with other kinds of things. We do have tools available for authoring structure maps and for executing structure maps. So you're not sort of on your own there. There's open source capabilities in both of those spaces. And all three of them are being used in real systems. I've seen structure maps being used For example, to take questionnaire response results in social determinant spaces and turn those into observations and conditions. We use concept maps even inside the core specification to map between CDA structures, for example, or version 2 structures and our code systems and their FHIR equivalents. And we actually require the inclusion of certain types of mappings in our FHIR profiles when we're defining resources to say where do certain kinds of things come from. Sometimes the answer is there's nothing that corresponds to this in V3 space or CDA space, but if there is, there's an expectation that those mappings are provided. I'm just going to jump past the slides that mysteriously disappeared because I know they used to be there. Something gone funky with all of my graphics. There's supposed to be a graphic here too. Technology is awesome. But that's how you find the FTC specification. That's how you find me. I'm also going to put in a quick plug for chat.fhir.org, which is the community that FHIR uses to support itself. There's 35,000 members or so, active members in that community. And you can ask a question pretty much any time of day or night, any day of the year, and have good odds of somebody responding within an hour or two, or sometimes even within a few minutes. There are different streams there for all kinds of topics. So whether you're interested in questionnaires or bulk data or clinical genomics or terminology, there is a sub-community there to ask questions or to even just search and see if somebody has already asked a question like this and get answers. So I did leave time at the end. We got 20, 25 minutes to answer whatever questions you have.